Hey, my name is Min and I would like to give a quick demo for the interactive walkthrough of the ARM immediate encoding. For this demo, I'll be showing you how to use this tool to learn how does ARM encode a positive number. So recall that to encode a positive number, we have to fit what is known as the most significant parts of the number into the bottom 8 bits, and then use a specific rotational amount to bring those bottom 8 bits back to its original position. If you had a number that could be represented less than 8 bits, like something like 64, then obviously you could just have this be your bottom 8 bits and then a rotation amount of 0, because you wouldn't need to rotate this back to its original position because it's already in its original position. This gets more interesting when you have a number that is longer than 8 bits, such as 261120 here. This is the whole number. As you can see, the most significant parts, these ones right here, extend well beyond the bottom 8 bits. So the question really is, can we capture the most significant parts of this number within these 8 bits? Because really everything else in this number are zeros. So they're not significant because the zeros will always be there, but it's these ones that really, in essence, encode the most important part of your number. So if we move on to this portion right here, we're asked to use these arrow keys to see if we can fit the most significant parts of this number into the bottom, and we can try to move it in, and it looks like it will work. We can indeed capture the longest trail of ones into the bottom 8 bits. So in essence, when we go to encode our number, what goes, so recall that there's 12 bits, 4 bits for the rotation and 8 bits for the actual number. So these guys will go into the 8 bits. So we're not done yet, because right now this entire number equals 255, which is not our original number. Our original number is right here. What we need to do is rotate this back to its original position, and we need to figure out how much we need to rotate it. Basically, how do you get from here to here? Because this is our original number. So this next part right here is intended for you to be able to figure out that rotational amount. So here's the bottom 8 bits copied back to here. Use these arrows to figure out how much you need to rotate back to match this original value right here. This is 261120. So let's just rotate it, and as you rotate, the tool tells you how many times you've rotated, because this really is the information that you need for those for the 4 bits of the 12-bit encoding. So if we keep rotating, so when you match the rotation, you'll see that the color matches with the correct 8 bits. So in essence, what we just did, in essence, to get from 255, the bottom 8 bits, to our original number, we needed to rotate it 22 times. So to sort of sum it all up, we can play this animation. This currently is 255 rotated 0 times, so no rotation is itself 255. If we play the animation, so as you rotate 250, the bottom 8 bits 255, these bits becomes different numbers, and once you hit 22, the bottom 8 bits fall into the correct original position of the 261120 number, and that's what you get. So this is how you would encode. One thing to note is that the rotation amount, the encoding for it, it's a little bit different. So the bottom 8 bits stays the same. Recall that this was the bottom 8 bits that we were able to capture, but this is not 22. This is 11. Because if you read this paragraph right here, then you'll know that the rotation amount is always going to be an even number from 0 to 30. So really because 4 bits, you can only go from 0 to 15. So what happens is that you get these the rotation amounts will be multiplied by 2 to get the actual rotation amount. So you will never get an 11 because it's not an even number. But in order to have a rotation amount of 22, what you would use is 11 in the 4 bits, because 11 times 2 is 22. So even though we know that it's 255 rotated 22 times gets you this number, the encoding says 11, and sometimes that can throw people off, but just remember that it's 22, and this is just sort of like a minor detail. So that concludes the demo for encoding a positive number using this tool, and there's also a separate demo for negative numbers, because that process is quite different.